Alright, on to the second one. Let's go. Let's get past those component vectors. Right, that component form of a vector. And I got them highlighted. When you look at your text, that's really what it's saying. I know the middle kind of screws you up a little bit with all those Q1s and P1s and squares. It's too much to read. But let's get into more frickin' notation here, huh? We're going to say that let's have some vector. Just be two numbers. I don't know. Maybe it's like the U vector is equal to 1, 2 or something. All right, and then it's saying you got some V vector, and this one's equal to, I'll call it 3, 3 or something. All right, and then let K be a scalar. So I don't know what K. Let's call it 7. That's a scalar. Just a freaking number. We have to be able to differentiate between a vector and a number. So we got to give the number a name besides number. You know what I mean? So we call it a scalar. A vector is a vector. It has both direction and magnitude. And a number is just a freaking number. Okay? Numbers are inside of vectors. So K is a scalar. Just a fancy way of saying number. All right. And it's saying that if we want to add two vectors together, like give two different pieces of directions, right? I need you to go east for a mile, I need you to go north for a mile. Hey, then once you get done with that, couldn't you give somebody a second set of directions? That's called addition of vectors, essentially. You're just putting your directions together. So it's saying just add up your freaking components. So it's saying if you wanted to add these two together, vector u plus that vector v, well, inside of here, all it's saying to do is just add your freaking components. Hey, take your x components and add them together. 1 plus 3. So let's put that in there. 1 plus 3. And then once you're done with that, say, hey, why don't you just add your freaking y values together? You know, like 2 and 3. So you find out that when you actually put both those vectors together, it goes to 4, 5. Because you're adding them up. Just as vectors behave so freaking nicely. It's like add. All right, well, add the frickin' numbers inside those frickin' little weird greater than, equal than, or greater than or less than symbols. Frickin' vectors are dope this way. All right, let's go to the next. It says a scalar multiple of k times u in the vector. More bullshit trying to confuse you on something that's not that bad. So it's saying if you want to multiply a number, so our scalar was 7. And it's saying if you wanted to multiply that by your u vector, well, our u vector was what? 1, 2. It just says bring the frickin' 7 and multiply them. And here's your new frickin' thing. So here it is, 7 times 1, 2. So 7, and what's 2 times 7? Isn't that 14? And you've seen it. Let's say, all right, 1, 2. So that means it would go something up like this, right? So 1, 2. And that 7 says, well, you just draw the frickin' thing 7 times. 1, 2, 3, 4, 5, 6, 7 times. All right, so wouldn't you be having to go tick, 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 tick all the way over to 7, and then go tick, tick, tick all the way up to 14 because you're just adding the freaking components? Absolutely. Scalars are simple. Vectors are simple. The notation sucks. But once you get used to it, it's not that big of a deal. Let's tackle a problem ourselves. We got two vectors. I got them set up really nicely. These are what we call cooked up. Cooked up. We got a 3, 4 vector. We got a -5, 12 vector. These would give you perfect hypotenuse. Lengths. Magnitudes. It's all the same shit. All right, but we're not even talking about that. So let's add our vectors v and w. Let's go. So, all right, here we go. This is equal to, all right, so we're supposed to take our x values and add them up. So 3 plus -5. All right, so 3 plus -5. And then after that, once we're done with that, we're supposed to take our y values. We're going to add those ones. So that's 4 plus 12. 4 plus 12. What do we end up with? I think this is 3. That's -2. And this one's 16. So we have a vector which says vector v plus vector w says go 2 in the negative direction of x and then go up by 16. Sweet. We found a frickin' vector. Yeah, we found it. We're awesome. We did it. There's vector v plus vector w. -2, 16. All we do is add the frickin' components up. Vectors behave nicely. Now we want to find what's 3 vector v's. What was 3 of those things? And you're like, dude, it's just 3 times the vector v. no 4. So don't we just bring that sucker in? I know how we can write it. This will be better. Why don't you just write your vector v in here? Put your 3 and put your 4 right there. And now inside, see this 3 that we're multiplying by? Bring the 3 in. And there it is. We got, what's 3 times 3? Isn't that 9? 3 times 4, isn't that 12? Dope. There's our 3 vector v's. No big deal. Let's do it again with 2 vector w's. Let's do it again with our 2 vector w's. So this time, let's write in our w's. What's the w? We got a -5 and a 12. So let's write in -5. Let's put in 12. And now we're going to take this 2 that's right there, and we're just going to multiply that 2 in by our components. There is nothing to this. Vectors are pretty much just adding, subtracting, and multiplying frickin' numbers. I think this is -10, 24. Dope! There it is! We did it! And now, it's like we're building up to do something. Oh my gosh, we're going to have to now do vector subtraction. Alright, let's go. Let's see if we can't figure out how to do it. This wasn't defined for us, so this is asking us to find 3 of those vector v's. So let's write 3 vector v's. Since we already figured out what it is, let's put it down here. So we're saying we want to take this. It's a 9, 12. And we wanted to go through, we wanted to subtract out our little what? -10, 24. That's what we're trying to do. My notation is not proper right now, but I'm just trying to get you to see what the hell's happening here. Aren't we actually just going to write it like this? Let's take our x component, the 9, and put that in there. And now we're going to, since it tells us to subtract, why don't we subtract? And we're going to subtract out whatever was in our x component, that -10. No biggie. Cool, now we're going to do the same thing on our y value. We're going to take our y value out. Oops, it's not a y value, that's just the y component, or the vertical component. And now we need to subtract out, because we're subtracting, our 24. Oops. Our 24. And what is our resulting vector? I think 9 minus -10, that's 19. And 12 minus 24, that's -12. And that's how we can take something like multiplying a scalar by a vector minus, or the addition of the -2 times the vector w. So there's our games. This is how we play them. Vectors are not rough. You just got to get used to the notation. Once you're used to the notation, you're off and running. I'll see you in the next one.